Okay. So this is the law of partial pressures. So what is partial pressure? So the partial pressure is the pressure of one of the gases in a mixture. And this value can be found using the ideal gas law, which we've written down below. And just a note, to find the total pressure of a mixture, what you'll do is you'll find the pressure of the individual components of that mixture, whether it's atoms, molecules, or compounds, whatever. You find the pressure of those individual parts, and you just add those together to find a total pressure. So that's essentially, that is the law of partial pressure, but you'll have like pressure total, let's say, equals the pressure of, I don't know, compound 1, pressure compound 2, pressure compound 3, on and on and on. And that is your total pressure. That's how it works. Let me see. I think I want to move that. That's what we'll do. Move it here. Yeah, like that. There we go. That makes sense. Okay, and then the ideal gas law. So the ideal gas law is, we kind of use it everywhere. In this case, we're just talking about something simple, partial pressures, but it does go into a lot of the things that we've been talking about regarding gases. In this case, though, we just need to pay attention to the ideal gas law itself. So PI, that stands for, or the P part stands for pressure. That I there is just, telling you it's of a specific compound. So if you were, say, finding the pressure of two compounds, two different compounds, one of them would be P1 N1, and the other one would be P2 N2. The I just, it tells you a number. So P, I don't know if I already said this, but P is pressure. N is moles, which can get a little more complicated when you have like mass and molar mass. We'll go into that when we specifically talk about the ideal gas law and deconstruct that. But there are other ways to solve it when you aren't exactly given moles. Then V is for volume. T is the absolute temperature. Reason why I say absolute temperature is because for things like gases, each atom in that gas is going to have like a slightly different temperature, slightly different speed, but just like with speed or like kinetic energy, there's an average, and that's that average that it's talking about is, the gas as a whole, what is the average temperature of all those atoms, so that's what that absolute temperature means. And we also have the R, which is the gas constant. There's another version of this R value with different values, which I think has like joules in it. But for the types of math we've been doing here, we don't need that. So it's just this number, and then you have, I'm just gonna write it out. So you have the liters, atmospheres over mole times Kelvin, and you want to keep those units in mind, because this R value is going to tell you kind of what you want to convert to, and I'll show you what that means later, which actually I guess later is now. So our example problem, and I went ahead and found some of those values just to save some time. The problem goes like this. You have a 7-liter gas tank at 6.9 degrees Celsius, and it's filled with 14.9 grams of sulfur hexafluoride gas and 3.73 grams of sulfur tetrafluoride gas. You can assume both gases behave as ideal gases, and that'll be covered in a different thing. And then you want to find the partial pressure of each, and then the total pressure of the tank. So, just the collection of information. We're given our liters here. You can write sig figs. That's 3 sig figs. As if it gives you those zeros instead of just writing 7 liters, probably means it wants you to consider those as sig figs. And temperature here, it's 2. I've had some people tell me that you use the sig figs of the original unit, but some people tell me it's the ones after. I don't think it makes sense, the one after, because after those conversions, you can get a crap ton of decimals. So I just go with the sig figs of, the temperature there. If that's ever not the case, or like, if I find out in the future that's incorrect, then I'll fix it. I'll fix it. I'll write a new video or whatever. But as far as I know, that's how you do it. So in this case, that'd be 2 sig figs. And you'll see that I converted this Celsius that they gave us to Kelvin, because that's what's needed with our R value.